today's session we'll be doing factoring and quadratic equations. So, first thing we're looking at is the greatest common factor. Which of the following is the greatest common factor of 4x cubed minus 16x squared plus 4x? So we're talking about greatest common factor, or we abbreviate it as GCF. We want to see what's the most common term that can be pulled out nicely out of all three of these terms. So when we're doing that, we're looking at our numbers separately and our x separately. So we look at our numbers, 4, 16, and 4. We see what's the biggest number that can be pulled out nicely or divided by, that all these numbers can be divided by. So the number that can be divided, all these terms can be divided by is 4. Because 4 can be divided by 4, 16 can be divided by 4, and then 4 can be divided by 4 again. So now we look at our x's. We have x to the third, x to the second, and just x. So the greatest common factor should just be 1x, because 1x can be pulled out nicely out of every single term here. Because if I were to pick x to the second, I can pull x to the second out of the first two terms, but I can't pull it out to the last term. That's to find a term that can be divided nicely. So in this case, our GCF would just be 4x. Right? So the answer is 4x. Okay, let's go with another one. So which of the following is a factored form of that expression? So this time, instead of, not only do we have to find the GCF, we actually have to do the process of factoring it out. So let's factor it out. So before we try to factor it though, we want to see, can this expression be reduced? In this case it can, because of our fraction here. So remember, we use the rules for exponents, in this case the quotient rule, in order to simplify before we want to factor. So when we're doing this, remember, we're doing term by term. We're doing the numbers, x's, y's, and z's all separately. So I do 56 divided by 14. That gives me just 4. Now, x to the third divided by x. Remember, using the rules of exponents, it's when you're dividing, you're actually doing a power to subtracting powers. So I do x, my top power is 3, minus my bottom power, which is 1. That should be x squared. Move on to my y's. Y to the second divided by y to the second. So it would be 2 minus 2, y to the 2 minus 2, which is y to the 0. But anything to the power of 0 is just 1. So we don't have to write it in this case. So let's move on to our z's. So let's write our base as z. Our top power is 1, while our bottom power is a negative 2. So it would be 1 minus a minus 2. That gives us 1 plus 2, which is z to the third. Okay? So all we haven't factored yet. All we did was we simplified this expression. So let's rewrite that second part of it. 16 x to the third z. Right? Okay, now we do the factoring, right? So just like last question, we want to see what's in common between these two terms. So we look at the numbers, the x's, and the z's. So we look at the numbers, 4 and negative 16. The greatest common factor between both of those terms is just 4. Now we look at the x's. X squared, x to the third. The biggest number we can pull out is x to the second. And z third and z, the greatest common factor is just the z. Okay, now we found our GCF. We actually have to factor it out this time. So we're factoring out, we open parentheses. I'm pulling out 4x squared z to both of these terms. So I'm doing it part by part. 4 divided by 4, that's 1. X squared divided by x squared, that's another 1. We're going to have z third divided by z. That's left with just z2, z to the second. Move on to the next term. Negative 16 divided by 4, that's a negative 4. And then x third divided by x squared, that's just x. And z divided by z is just a 1, so we don't have to write it. So we're done, and we close our parentheses. So the factored form of this expression is 4x squared z times z squared minus 4x. Right? Let's check. There we go. 4x squared z times z squared minus 4x. Alright, so now factoring. So this time we're still factoring, but this time we're given this is called a quadratic equation. So before we start factoring, let's see what a quadratic equation is. So let's write our quadratic equation. The most standard form you'll see it in the most is the form y equals to ax squared plus bx plus c, which looks like this form. This is the form most standard form you'll see it in a lot. So what do we have to do with this, right? So we need to factor it. So if you notice, if we go back to our question real quick, the answers here are in factored form. We have to get this to look like one of these. So what do? There's a lot of methods to do this. There's a guessing method and so on and so forth. But the easiest thing to do would be the AC method. Because the AC method ensures you a way to factor it. It can be used for the most part on any quadratic equation. So when we look at this, we look at what is our A value and what is our C value. The A value is always the first value that's connected to the x squared, the coefficient of the x squared. In our case, we don't see a number here. You always assume that coefficient is just 1. Now we move on to the C. The C is the very last term here. So the very last term of ours is a negative 21. You always want to make sure that you take the sign of it as well. If it's a negative 21, you want to take it as a negative 21. Now what do we do? So AC, it's A times C. So we take our two numbers, our A and C's, and we multiply. So 1 times negative 21 gives us negative 21. Now what we do is we find factors of negative 21 that can be added up, that can be combined to get 4x. So we know negative 21, or 21 is 7 times 3. Now you think about it, we need them to add up to get you 4x. And this is negative, right? So in order for a number to be negative, when you're multiplying, is they have to be one positive, one negative. So this, in this case, should be a positive 7 and a negative 3. Because 7 minus 3 gives me 4x, and 7 times negative 3 gives me a negative 21. So now we have that, what we do is we replace. We replace 4x with 7x minus 3x. So let's write it up here. 7x minus 3x minus 21. So we haven't changed the nature of our expression, because in reality, 7x minus 3x still gets me 4x. So I haven't actually changed anything. I haven't disobeyed the rules for that. So now, when I have 4 terms, I group them up like so. Now that I've grouped them up, I do a factor by grouping. I find greatest common factor of these two parentheses separately. So we look at the first set of parentheses, x squared plus 7x. What's the greatest common factor? So we see that they both have an x in common. So once I factor it out, I should be left with just x plus 7. Right? Okay, now I move on to my second set of parentheses, negative 3x minus 21. So they don't have an x in common, but they have numbers in common. Between negative 3x and negative 21, they can both be divided by a negative 3. And you want to pull out a negative if you have a negative here. So in this case, if it's a negative 3x, you pull out a negative 3. So I'm getting left with x plus 7. So whenever you're doing this factoring method, these two terms inside the parentheses here should always be the same. You always want to check if they're always the same. In this case, they are. If they are the same, you pull it outside. You pull the x plus 7 out, and then you're left with what's called your leftovers, is these two outside terms. And you put them together. So our outside terms are x minus 3. So this is the factored form of our quadratic equation. So you can always check in order to see if this works or not. To check it, you use a process called foiling. Foil. F-O-I-L. So foiling, how that works is let's rewrite this expression, x plus 7 times x minus 7. Minus 3, I'm sorry. Okay? So, FOIL stands for first, outer, inside, last. So if I draw my arrows when I'm multiplying first, I'm doing first here, outside, inside, and last. So first, x times x gives me x squared. Outside, x times negative 3, negative 3x. inside 7 times x is 7x. And then 7 times -3 is my last, is -21. I combine like terms. I see that I have x squared plus 4x minus 21. So if you notice, that's our original expression here. So it tells us that this x plus 7, x minus 3 is the factored form of our quadratic equation. Right down here. So the order you write doesn't actually matter, because you could have written x minus 3 first and then x plus 7. As long as the positive 7 and the negative 3 are still the same notations, it should be fine to order it. The reason you would get x minus 3 times x plus 7 is if you go under here, you wrote -3x and then positive 7x first. Either or would be okay. So let's check if that's our answer. There we go. X plus 7 times x minus 3. Alright, let's do another one. So, x squared minus 14x plus 49. So again, we use the AC method. So we say our A term is 1, it's the coefficient in front of the x squared, and our C term is the last term, which is 49. So, now we multiply them. 1 times 49 gives us 49. Now you want to find factors of 49 that multiply, that multiply to get you 49, that add up to get you -14. So factors of 49, we know it's 7 and 7, but they need to be a -14, they combine to get -14. Only way for that to happen is if they're both -7s. So now we replace. We rewrite this as x squared. Instead of writing -14x, I write this as -7x, -7x plus 49. Now that I have my 4 terms, I group the first 2 and the second 2. I find what's my common between my first term, my first parentheses. My greatest common factor is x. If I factor it out in x, I'm left with x minus 7. My second parentheses, I find the greatest common factor. Greatest common factor of the second set would be a -7. And again, I'm left with x minus 7. So you notice, our parentheses are the same. We factor that out, x minus 7. And you notice our leftovers, in this case, are going to be another x minus 7. So that should be our factor form. And again, if you want, you can check by using foiling. If you were to FOIL this, you will see that you'll get the original expression again. Now, you notice x minus 7 times x minus 7, they're both the same term. So in reality, you can write this as, if you wanted to, x minus 7 quantity squared. So your answer could either look like this or this, depends on the question. So let's say, in this case, let's go with the x minus 7 squared. So that is our factored form of our quadratic equation. So let's check. There we go. X minus 7 squared. Right. So again, which of the following is equivalent to 8x squared minus 22x plus 15? So, as mentioned before, you could, when doing quadratic, when trying to factor a quadratic equation, there are some other methods as well, which is one of them is the guessing and checking method. But in this case, it would be a little bit hard to guess and check because of the numbers that are a little bit bigger than what we're working with, right? So the for sure way would always be the AC method. Because no matter what numbers you have, AC method, for the most part, should work. Okay, so we see what's our A and what's our C. Our A in this case is 8, and our C is a positive 15. So, again, AC, we take another multiply. It gives us 120. And we need to find factors of 120 that add up to get you -22. So even though 120 is kind of a big number compared to the last couple of numbers we've been working with, you notice that 120 is a factor of 10. So when you divide 120 by 10, that should give you 12 times 10. And if you notice 12 and 10, they can be combined to get you a -0.2. They can do that by having them both be negatives. So now that we've found factors, we replace the negative 22x with negative 12x minus 10x. That's right over here. 8x squared, replace it as negative 12x minus 10x plus 15. So, again, now that I have 4 terms, I group them, my first 2 and my second 2, and I see what is the greatest common factor of my first set of parentheses. So between 8 and 12, my GCF would be 4, and x squared and x would be an x. So when I pull out a 4x, I should be left with 2x, and I get minus 3. Now look at my second set of parentheses, negative 10x plus 15. I don't have an x in common, but I have numbers in common, because in reality I can pull out a negative 5, and I should be left with 2x minus 3. Again, my parentheses are the same. I pull that outside, factor it out, and my leftovers should be 4x minus 5. So that should be my factored form of my quadratic equation. 2x minus 3 minus 5. Okay. So let's check if that's the answer. 2x minus 3 times 4x minus 5. Alright. Move on to the next one. Okay, again, factor w squared minus 144. So, question is, you want to look, is this a quadratic equation? So, if when you're more used to the quadratic equation, y equals to ax squared plus bx plus c, in this case, you don't see that bx value, right? But this still is a quadratic equation. The reason it's a quadratic equation is because it's a squared here. It's a power of 2. That indicates that it's a quadratic equation. So, to make things nicer for ourselves, let's write this as w squared plus 0w minus 144. Because I know 0 times w gives me 0. So that just goes away, I'm left with the original. I just wrote this so that it would be easier to see when we're doing our AC method. So, just like before, apply the AC method. Our a, again, is 1, because that's the coefficient in front of the w squared. And our c is a negative 144. We take them, we multiply. Gives me negative 144. So, I need to find factors of negative 144 that add up this time to get me that middle, which is 0. The only way for that to happen is we know 144. In order to them to add up to be 0, they have to be the same number. In this case, it's 12 and 12. And they need to be opposite signs of each other. So, one positive and one negative. So now we replace. Rewrite this as w squared plus 12w minus 12w minus 144. Because again, positive w, negative 12w, they cancel out. You should have a 0 in the middle, which essentially would just be w squared minus 144. So, I group up my first 2 terms and second 2 terms. Now I find the greatest common factor of my first set of parentheses, which is just a w. And I'm left with w plus 12. And then I look at my second set of parentheses, negative 12w minus 144. I can factor out a negative 12. And I'm left with w plus 12 again. So, my parentheses are the same. I factor that out. And my leftovers are w minus 12. So that should be the factored form of our quadratic expression. So let's write this as w plus 12 times w minus 12. So, let's check if that's the answer. Right. Even though the orders are the same, as long as one of them is positive and one of them is negative, that should be okay. So, this quadratic expression is actually it's a unique one. In this case, it's called a difference of squares, because difference is negative, while squares, because both of these numbers squared, because you notice w squared can be split into w and w, while 144 can be split into 12 and 12. And you notice that the only difference is that one is negative and one is positive. So there's actually a form for this. So let's apply that difference of squares into our next question. The reason why is because if I were to try the AC method for this one, right, my A term would be 36, and my C term would be 49. That's a very big number that we do if we want to multiply it, right? So we don't want to do that. So let's try the AC method for this one. Or sorry, not AC method, the difference of squares. So, difference of squares, difference of squares, that takes A squared minus B squared can be factored into A plus B, A minus B. So let's apply that form to our expression. So let's look at what we have, right? 36x squared minus 49y squared. A squared, that's the first term, 36x squared, while b squared is just our second term, which is 49y squared. So we have a squared and b squared. What we need is a and b. So a, look at a, right? So we look at what can be squared to get you 36. 6 squared will get you 36. And because that's an x squared, the a by itself should just be 6x. Same thing for our b. Our b, 49, think about what squared gets me 49. That's 7. And attached to it is just a y. So in reality, the factor form of this expression using the difference of squares should be a plus b times a minus b. So 6x plus 7y times 6x minus 7y. So that should be the factor form of the expression using the difference of squares method. There we go. 6x minus 7y times 6x plus 7y. And in the end, order of it doesn't matter as long as one was negative and one was positive. Alright. So keep in mind though, this only applies, the difference of squares only applies if it's a minus sign. If you see if it's a plus sign in the middle here, exact same expression with a plus sign, you actually cannot factor that. So just keep that in mind when you're working. Okay? So let's move on to another one. So, what we've been doing so far is we've been factoring. All we've been doing is factoring. Now, we apply that factoring to solving a quadratic equation. So let's look at this expression. Solve the following equation. X plus 9 squared minus 36 equals to 0. So let's see what we do first. So when you see x plus 9 squared, you automatically think of this as x plus 9 times x plus 9. Right? And when you see x plus 9 times x plus 9, you should automatically think about FOIL, right? Using the method FOIL. So when we're foiling, we do first, outside, inside, and last. So my first terms, x times x gives me x squared. Outside, x times 9, 9x. Inside, 9 times x, another 9x. And then my last 9 times 9 is 81. And then I bring down the minus 36, equal that to 0, right? Okay, so then I want to combine like terms before I do anything else. So I notice that I have 9x and 9x, that gives me 18x. And then 81 minus 36 should be 45. And that's equal to 0. Okay? So now I see it's a quadratic equation. So in order to solve a quadratic equation, you need to factor, right? So just like we did before, and before we do anything, whenever you solve a quadratic, whenever you have a quadratic equation, one side always needs to be 0. So at all times, no matter what you're doing, always bring everything over to make it equal 0, at least on one side. So to factor this, we did what we did before, AC method. So this time our A is 1 and our C is 45. And 3. So now we replace them inside, 18x, with 15x plus 3x. That's 45. Okay. Now I group up my terms for my first 2 and my second 2. So I see what's my common for my first set of parentheses. That should be x. What's left over should be x plus 15. My second set of parentheses, I can pull out a 3. And again, I'm left with x plus 15 equals 0. Okay, so I see that x plus 15 are in my parentheses, that's in common. I pull that out. Now my leftovers should be x plus 3. So far, all we've been doing is factoring, just like we did in the last couple questions. Now the last step to it is, now that we have it in factored form, again, in order to solve a quadratic equation, it needs to be in factored form. I just set them separately equal to 0. So I set x plus 15 equals 0, and then x plus 3 equals 0. And I solve for x for both of them. So I subtract 15 both sides. X is equal to negative 15. And I subtract 3 over here. X equals to negative 3. So my solution set would be negative 15, negative 3. So 2 answers. Okay, so let's check if that's correct. So it should be negative 15, negative 3. Not sure why it's not showing up that one. There we go. Okay. So let's do more solving. Okay, so solve the equation again. So this time we're dealing with fractions. So just like last time, before we want to do anything, in order to solve this, we need to clear the fraction. Remember, to clear the fraction, you want to find the LCD, the least common denominator, right? So when you use this time, our denominators are 3 and x minus 3. So even though you have x minus 3 here, remember, your LCD is what's the least common, right? When doing an expression, in reality, the least common denominator would just be the 2 denominators multiplied by each other. So our LCD should be 3 times x minus 3. So in order to clear the fraction, what we need to do is we need to multiply the whole expression, the whole equation, by our LCD. 3 times x minus 3. So when I'm multiplying this, I'm distributing it, this LCD, to every single term on the inside of my parentheses. So I would write this as 3 x minus 3 times 3x plus 6 divided by 3 minus 3 times x minus 3 times 4x over x minus 3 equals to 3 times x minus 3 times x. So before I try to FOIL or anything like that, I want to see what can I cancel first, right? So I notice that for each fraction, I see that, oh, I can divide 3 divided by 3. I cancels that. My second fraction, I have x minus 3's on top and bottom. I cancel them. And I can't do anything with my last term, so I'll leave it as it is. So let's rewrite this as x minus 3, 3x plus 6, minus 3 times 4x, And then because multiplication, doesn't matter the order you write it in, I can write the 3x first, and at the end I write x minus 3. Just to make it a little bit easier for us when we multiply. Okay, so I see this. I may think about foiling. Let's draw our arrows. First, outside, inside, and last. So x times 3x, I'm sorry, is 3x squared. X times 6 is 6x. Negative 3 times 3x, negative 9x. Negative 3 times 6 is negative 18. And I'm going to go ahead and do distribution on these as well, all in one go. So negative 3 times 4x is negative 12x. And I have 3x, I distribute, I get 3x squared minus 9x. So all I did was we just distributed using FOIL. Now, combine like terms. So we notice that 6x minus 9x and negative 12x can all be combined. So 6x minus 9x is a negative 3x, minus 12x is a negative 15x. I have 3x squared minus 15x minus 18 is 3x squared minus 9x. Okay? So when we're talking about quadratic equations, in order to solve them, we want to bring everything over to one side. Because I have more terms on the left than I do on the right, I want to keep these over there and bring the ones on the right over. So to bring it over, I subtract 3x squared, both sides. So you want to put it under what's in common. So the squares, put them over each other. And to get rid of negative 9x, I add 9x and put it right under the negative 15x. So the right side, these cancel. So if you notice though, 3x squared minus 3x squared, that cancels as well. So I'm left with negative 15 plus 9x, that's negative 6x minus 18. And the right side all equals just 0 now. So this becomes just a linear equation. So solve for x, we want to get it by itself. So we add 18 both sides. So negative 6x equals 18. And your final step, if you divide both sides by negative 6, so x is equal to negative 3. That should be our answer. Okay. So first thing we do is we want to find the LCD, right? LCD of any is just the product of the two denominators together, in this case. Multiply everything by the LCD, cancel it out, using foiling and distribution laws, and combine like terms, and then we'll get our answer. In this case, we, coincidentally, our x squares cancel out, but it's not always the case. Just that if you were to get this point, you might have to do some factoring like we did in the last question. Okay, so let's check, that's the answer. X equals negative 3. Alright, let's move on. So square root property. So if the square root of w plus 3 equals to w minus 3, w equals to what? So we're looking for w. Solve for w. So general square root property is the square root is the opposite of a square. So they're opposite of each other. So if you were to say the square root of x, to get rid of square root of x, the square root, you have to do the opposite of it, which is squaring it. And what that does is that cancels the square root, left with just x. So we have to apply this property to our equation. So now we look. I have a square root. Whenever you solve for anything with a square root, an equation with a square root, you want to get rid of that square root first. That's the first thing you want to do. So I have to square the side to get rid of it. But what I do on one side of the equal sign, I have to do to the other as well. So on the left side, this and the square root cancel, left with w plus 3. But then on the right side, w minus 3 squared, I can write that as w minus 3 times w minus 3. So, two parentheses, when you see that, you have to automatically think about foiling. So we foil first, outer, inside, and last. So in first term, w times w is w squared. W times negative 3 is negative 3w. negative 3 times w is negative 3w again. And then negative 3 times negative 3 is a positive 9. Let's rewrite this left side. W plus 3. Okay, I combine like terms. I see that on the right side, I can combine the negative 3 w's. That gives me negative 6w. This time, I have more terms on the right than I do on the left, so I want to bring these left over to the right side. Because remember, when you're solving quadratic, one side always needs to be 0. 3 minus 3 cancels. So I'm left with, let's rewrite this first. So because it's equal to 0, we can write this on the left. W squared minus 7w plus 6 equals 0, right? So we see quadratic equation, we need a factor to solve it. To factor it, we have to use the AC method, right? So AC method, this time we're A, let's write up here. A is 1, C is 6, we multiply, that's 6. We have to find factors of 6 that add up to get you negative 7. That would be a negative 6 and a negative 1. So, I rewrite this as w squared minus 6w minus w plus 6. Let's put it as a minus 1. Now I group up my first two terms and second two terms. So what's in common with my first one, first parentheses is w, left with w minus 6. My second one, between negative 1 and 6, only a negative 1 would be in common, left with w minus 6. And my parentheses are the same, so I pull out w minus 6. I'm left with w minus 1. And remember that all this should still be equal to 0. So now that we factored it, we can set them separately equal to 0. So if you solve for w, I add 6 both sides. I get w equals 6 is one of them. And I add 1 both sides. So w is equal to 1. So normally you'd say, hey, that's our answer, 6 and 1. But because we're dealing with square roots, we have to double check, right? Whenever you're dealing with square roots, you always want to double check your answer. So let's rewrite this. Let's rewrite this expression, this original equation. W plus 3 square root equals w minus 3. So that is our original equation. Now we need to check if both of these terms make sense. So check. Right? So when w is equal to 6, right? So we plug it in. We plug in 6 as w. So we have 6 plus 3 square root. And we're checking. When you're checking, you can put a question mark above the equal sign. And you have 6 minus 3. So 6 plus 3 is 9. Square root of 9. 6 minus 3 is 3. Square root of 9 is 3. So 3 is equal to 3. That makes sense. So w equals 6 would be an answer. Let's check when w is 1 though, right? What happens when you have w equals to 1? So you have 1 plus 3 square root. We're checking that's equal to 1 minus 3. So 1 plus 3 is 4. 1 minus 3 is a negative 2. Square root of 4 though, that's 2. So 2, we're saying 2 is equal to negative 2, but that's incorrect. Because 2 is not equal to negative 2. So in this case, that would be false. So that would be wrong. So in our case, the only answer would be w equals just 6. So even though you did the arithmetic right, you always want to double check because the square root property, right? Square root property is you always have to check. Whenever you see, when you get your answers, you want to double check to see if it's correct or not, if it makes sense in your equation if you plug it in. So now that we have that, let's see if that's the answer. Right? Okay. So the answer is just 6. So be careful, right? Even though 1 and 6 is an answer, you always have the square root property always double check what you have as answers. Even though you have two, plug them back in and see if they work or not. Okay? So, let's do another one. Again, use the square property, solve the equation. K squared minus 5 equals to k minus 5. So, again, we have a square root. We need to get rid of it first, right? First thing we do is we square one side. That means we have to square the other. So, left side, these can cancel. I'm left with k squared minus 5 equals to k minus 5 squared. So instead of squaring this, let's look at this left side first, right? So k squared minus 5, in this case, can't really do anything, right? So let's check the right side and rewrite k minus 5 squared as k minus 5 times k minus 5. And the left side stays as k squared minus 5. So the right side, we FOIL again. Let's do our arrows. First, outer, inside, and last. So, but for first, k squared, k times negative 5 is negative 5k. Negative 5 times k, another negative 5k. Negative 5 times negative 5 is positive 25. Left squared k squared minus 5 still. So on the right, I can combine like terms. Right, k squared minus 10k plus 25. Left side is k squared minus 5 still. So I see I have more things on the right than I do on the left. So let's bring them over to the right side. So subtract k squared both sides. And I add 5 both sides. So notice that both sides on the left cancel. And again, the k squareds cancel on the right as well. So I have negative 10k plus 5, this is plus 5 over here. Negative 10k plus 25 plus 5. So negative 10k plus 30 is equal to 0, right? So, I have a negative 10k plus 30. Let's keep that negative 10 on the left side. Subtract 3, 30. So negative 10k equals to negative 30. And divide by negative 10. So k should be 3. But again, because it's a square root, we need to check. So let's rewrite the original. K squared minus 5 square root equals to k minus 5. And we're checking if when k is equal to 3, right? So let's plug in k as 3. So it would be 3 squared minus 5 square root. And we're checking that's equal to 3 minus 5. So 3 squared is 9 minus 5 equals to 3 minus 5 is a negative 2. 9 minus 5 is 4 square root. But then square root of 4 is a positive 2, which does not equal to negative 2, does it? So in this case, because this is false, our only answer doesn't work. So because our only answer doesn't work, there should be no solution. Right? So our answer is just no solution. There is no k value that will make this expression true. Right? So let's check. And no solution. Right? So that's it for this session.